All right, thanks again everyone for joining in. My name is Ryan Navarro, and I'm an applications engineer here at Hawkridge. Again, this webinar is called Why is it called SOLIDWORKS Premium? And basically the goal here is to go over the SOLIDWORKS Premium exclusive features, so the features that are only in SOLIDWORKS Premium. One of the big benefits of SOLIDWORKS Premium is that you also get all the features that are in SOLIDWORKS Professional and SOLIDWORKS Standard. So there are a lot of features in SOLIDWORKS Premium that we're not going to be going over today because of that reason. But I'll point out what they are towards the end of the presentation. So if you're interested, we have a lot more videos and content on what all those features are there. But again, focusing on the exclusive features of SOLIDWORKS Premium, by far my favorite one would be SOLIDWORKS Simulation. That's our FEA or stress analysis tool, design validation tool, essentially to be able to put virtual loadings on your parts and predict their performance, parts and assemblies. We have SOLIDWORKS Motion, which is a kinematics tool that allows you to work with, say, linkages or powertrains and apply motors and forces and see things like torques and accelerations out of it. We have the routing tools, which are useful for pipes, tubing, or wiring and cable harnesses. So those are basically automatically sweeping your 3D paths for those types of things and allowing you to create drawings and other nice outputs for your routes, and just a bunch of other features that have made their way into Premium that we'll go over. Surface flattening capabilities, allowing you to flatten any compound curved shape to a flat state. Import capability for CATIA files, and also costing for assemblies. So there's a lot of things that you get exclusively in SOLIDWORKS Premium, and then you're also getting all the functionality of SOLIDWORKS Professional and SOLIDWORKS Standard as well. So this is going to have to be a pretty quick overview of these features. As you can see, there's a lot of them in here. So we're not going to be going very far in depth, but we'll be showing you, kind of the key things you need to know about each of these when you want to use them. And then we have great other content sources available too if you want a deeper dive into any of these. So as far as SOLIDWORKS Simulation, SOLIDWORKS Simulation is finite element analysis built right into SOLIDWORKS, and it lives on the CAD model, the part or the assembly. So basically you're going to be going in and applying your forces and loads to the model, and it's going to be predicting stresses, displacements, whatever parameter you're interested in from that. And it can be as simple or as complex as you want it to be. So SOLIDWORKS Simulation can be used on very small parts, simple parts, or it can be used on a large assembly. There's no artificial limit to how big the problem can be. So what I'm going to do is load up SOLIDWORKS and show you a quick walkthrough of setting up a example assembly here in SOLIDWORKS Simulation. So here I just have a small piece of a automotive suspension. It's a steering bracket for a car. And we're going to load up my SOLIDWORKS Simulation add-ins. This is the first thing to realize. If you've ever used Simulation Express, that's something that's in all versions of SOLIDWORKS under the Evaluate tab. And that's very limited in terms of it can only do a single part for analysis, and it can only have very limited loads and ways to interpret the results. So if you have SOLIDWORKS Premium, you want to make sure you go to your SOLIDWORKS add-ins either through that tab on the command manager or through your pull-down menu and going to add-ins here to enable the full SOLIDWORKS Simulation tool. Now there are a lot of different packages of SOLIDWORKS Simulation. So with SOLIDWORKS Premium, what you're getting is what's called linear static stress analysis. So when we come over here to click New Study, they'll have these studies kind of segmented by the module of simulation that you have. So for SOLIDWORKS Premium, again, you'll be getting just this static module right here. We have higher level versions of simulation as well that will enable all these other types of studies that you can be using. But even though I say just getting linear static is a very, very powerful type of study, and it's what's used for probably the vast majority of engineering problems. So what we do is we just click the check mark to create our study, and then simulation basically gives you its own feature tree here on the bottom left, integrated nicely with your SOLIDWORKS feature tree on the top. And any materials already applied to your parts will carry over here to the simulation feature tree. So we can see if we had SOLIDWORKS materials applied, they would have automatically had those appearances applied. I'm just going to come in and apply a material manually. And I said appearances, really what I mean is when you apply a material in SOLIDWORKS, you think usually you're just changing the appearance and the density. But if you look in here, you'll see that there's all these engineering properties as well. Elastic modulus, Poisson's ratio, mass density, so yield strength even. These are the parameters that simulation needs to solve a stress analysis on here. So if I choose whatever alloy I want to, choose an aluminum alloy. And you can of course create your own materials here as well. Now those material properties are loaded up in simulation, and I get the little check mark next to that part to signify that. Because we can simulate assemblies, there's multiple ways we can define interactions between parts. So we have what's called here component contact. Right now it's set to bonded, meaning these parts are basically glued together, like fused together. But there's other settings there. You can do like a sliding contact called a no penetration. If you want parts to slide on each other, you can actually do that in the simulation. And we have all kinds of virtual connectors. So if you have pins and bolts and springs and things like that, you can add those in here. So just to show you for reference, even though I don't have the back plate here, if I had the back plate that this suspension bracket bolted to, I could actually put in a virtual bolt. I could just choose those two edges. I can put in the preload on that bolt if I want to, and it will put in a bolt there that would actually represent the preload and all the forces accurately of a bolted joint, but without me having to go through the hassle of modeling that. We had a question in chat, is this the FEA from Abacus? It's actually not. This FEA was formerly known as Cosmos. So some years ago, SOLIDWORKS purchased Cosmos. You might have, if you're a longtime SOLIDWORKS user, you remember Cosmos Works. And that's another really long-standing solver that's been out there, and that was integrated into SOLIDWORKS Simulation. So I'm just going to delete that bolt right here. I don't actually need that one. And choose how I want to apply my loads and fixtures here. So this is really the only major decisions you need to make when you're setting up your simulation. You know, apply your materials and then choose how is the thing restrained and how am I going to be loading it. And I always just tell people just set it up like it would be in real life. So in this case, I'm going to use, you can see these different fixtures I can choose from. If I just right click on the fixtures, and if I go in here, it'll show me little previews of what I'm actually doing when I apply these. So I want to choose what's called a fixed hinge, just on these, where these would be bolt holes, you know, and fix those three faces there. And then I'm going to choose what's called a roller slider on the back plate of the suspension bracket here. And you'll see that those little green arrows also show me the way it's restraining the part, so it can't move in or out of that plane that I'm selecting on. So basically I'm just approximating the fact that it's bolted to something else behind there. And as you'll see, we could go to more detail. We could include those other components and actually put in the bolts, right, if you want to. But it's all about what you're trying to achieve from your study. This is a really quick one to set up here. We're going to just say fix those holes, fix the back. Come in here and say apply a force onto the model. I choose the face I want to apply the force to, and choose the direction I want it to apply in, along an edge, for instance, and then set my loading. Okay, and when that's done, that's essentially all I need to do to run the study. I can come up here and click Run the Study, and it will automatically mesh and solve this analysis. So meshing is that behind-the-scenes step where it's breaking it down into finite elements in order to solve. That's how the computer solves the math, right? But if you don't care about that, you just click Run, and you'll see your stress results here. I can see displacement results and see how much it's displacing. What you see on the screen is an exaggerated displacement, so that's useful if we animate. We can see the direction that the part would be deforming in. But if we look at the real displacement, you see it's about 0.1 of a millimeter, so very small real displacement, and it says it's exaggerating it 74 times so that we can see that. You can always switch to a true displacement mode to see the real displacements, but typically, you know, we're not expecting to see really large displacements under our working loads here. And back to the stress plot, that shows me where, you know, areas where the high stress is occurring. I can, there's a lot of neat things you can do from this legend right here that they've integrated. So you can just click on the top of the stress number and show an annotation, and that will show you where the peak stress is. You can rescale the legend right here just by typing in it to rescale the color scheme to different numbers if you want to. I like to right click sometimes and show the mesh. That shows me that finite element mesh broken down over the model, and we have full control over that mesh. We can increase the density of it, refine it in certain areas if we want to. There's a lot of control there that we can use. And then there's a lot of tools to interpret the results in more detail that, again, you wouldn't have in a simulation express. So we can probe and basically choose points anywhere we're interested in and get exact measurements there. We can probe along edges if we want to, and actually graph. So I can actually graph stress along edges if I want to. I can export any of these graphs or charts to Excel if I need to do more advanced interpretation of the results. We can certainly, I saw a question come in on changing the deformation scale. We can certainly change that. So if you just double click on any of your plots, you have advanced settings. So I can say go to true scale or go to some user defined scale of deformation, and you'll see once I make that switch, the part moves in such a way that even if I hide the stress plot, you'll see it's almost a negligible deformation there on it. Because again, 0.1 of a millimeter, quite small. So those are the most basic functionalities of it. Now, in my opinion, one of the best things about this tool is that, as I mentioned before, the setup is all stored on the CAD model. So now that I save this file, for instance, I can go back to my regular SOLIDWORKS modeling, and no one has to even know that there's a simulation study living on that part or assembly. And if I want to try making a design change, maybe I think I can have more stress in the model. I'll come in and I'll reduce the thickness of one of these webs, just rebuild the model, it updates. And when I go back to my simulation study, it's all the loads and fixtures and everything are already still there. And it just has a little flag on me. It warns me, hey, the mesh and the results are out of date. So all I would need to do now is just click run again, and I would get instant feedback on how much the stress has increased, how much the displacement has increased with that design modification. So now I can see I went from 115 or whatever I was at before to 130 megapascals of stress. And if you're not familiar with the yielding and all that, you can just define what's called a factor of safety plot. So factor of safety plot will just show us areas of the part where yielding is like to occur. So this shows me my minimum factor of safety, which is 2. And it's just showing me that in those regions, if I were to double the load, I would get potentially some yielding or failure of the part. So a lot of times we're designing to a factor of safety, so we can just look at a factor of safety plot directly within the simulation. But yeah, I have the ability to flip back, adjust the model, come back, rerun the study, and that allows you to manually iterate and basically try to optimize your design if you want to, or just test different design changes. And you could also create different configurations and set up different studies. You can see all these other studies I have just on the bottom here to keep track of all these different things I've tried or different loading scenarios. So that's SOLIDWORKS Simulation in a quick nutshell. The module that comes with SOLIDWORKS Premium allows you to analyze parts and assemblies. As I mentioned, it doesn't need to be as simple as this example. I actually have a larger scale example here where same application, but in this situation, we're looking at the larger system. So if you weren't sure, like I said, if I wasn't sure how to represent the loads and fixtures on that steering bracket, I could always just take a look at the larger assembly, with the whole suspension of the car or a larger chunk of the suspension, and run a stress analysis on that. There's really no limitations, as I pointed out, no artificial limitations on how large of a stress analysis you can do. It's just dependent on your computer and how much hardware you have. As you saw, that one on the steering bracket on its own ran in seconds. Something like this would probably still run in under a minute, I would imagine. So you can do some pretty large scale analysis these days. It's not like the old days when FEA was this really complex thing you had to run on a supercomputer. Nowadays, it's really attainable. You can get really quick design feedback. And with all these things I'm showing you today, there's tutorials built in. So if you just go to your help tutorials, there's a whole bunch of tutorials on simulation. So these are just self-guided tutorials to help you through there if you're looking to get up to speed and actually start using these tools. Definitely recommend that. All right, so I want to keep the move on since we do have a lot of cool features to cover today. I'm going to close out of these SOLIDWORKS simulation examples and even unload my simulation add-in. And the next thing I want to show you is SOLIDWORKS Motion. And here are just a couple examples of some more complex large-scale assemblies that we actually cover in our simulation courses as well. So if you're interested in learning really the ins and outs of simulation, we offer the training courses there to go through all those details. So motion analysis is another type of simulation that you get within SOLIDWORKS Premium. This one's what's called rigid body motion. So the thing with SOLIDWORKS simulation is things usually aren't moving around a lot on the screen, as we saw. If you have a lot of like linkages and mechanisms and things, those are usually better suited for this tool, motion analysis. And basically it treats each part as perfectly rigid. That's what we mean by rigid body kinematics. So it's good for looking at like overall system performance, whereas you'd use the SOLIDWORKS simulation for analyzing the strength of a single part or particular parts of an assembly. So just to show you a quick example of what, when you might use motion, I have a quick file here I can load up. And it's like a lift chair for a medical application. And so again, on my add-ins tab, I would load up SOLIDWORKS Motion in this case. And basically motion is going to allow you to work through the SOLIDWORKS animator interface. So if you've ever used this is the same interface I would use to just make an animation in SOLIDWORKS. So basic version of SOLIDWORKS allows you to make pretty animations with it, but it's not doing anything physically accurate. It's not going to let you make engineering decisions. Motion analysis allows me to put in motors and forces. As we can see here, I have a linear actuator basically defined on this, what would be the actual linear actuator part in motion in SOLIDWORKS. So it's just saying push up with at a certain rate. And then what that allows me to do is calculate the motion analysis that's going to actually show lifting that chair up and down, which you think, okay, big deal, I can do that with SOLIDWORKS mates, right? Or I can do that with just a simple animation. But the big difference here is now I can come in and I can plot quantities. So I can plot things like what's the power consumption of the motor, what's the torque required. So I can choose, for instance, plot power consumption of the motor and see over time. So if you're actually trying to size a motor, looking at a spec sheet and saying, what do I need for the force rating or power rating? We can make those types of determinations using SOLIDWORKS Motion. And there's just other nice things you can do if I'm interested in collisions or anything like that. I can come in here and I can do a type of plot called a trace plot. This is one I always like to show. A trace path allows me to click any point on the model, and it will basically show me the swept path that produces as it travels through its range of motion. So if I click play, you'll see that I just chose the point at the end of the chair, and it shows me the path that travels through the range of motion. And that can be very useful if you're trying to design around something that's moving around, right? You can figure out what kind of clearance cuts and things you need to do to prevent interference. So in the same token, this is saved on the assembly part. So you can go in, make changes to these linkages, rerun the motion study, and get instant feedback on, did I decrease the power consumption requirement? Did I speed up the acceleration, or whatever you're interested in optimizing? So there's a lot more we can talk about there, but basically it's useful for your kinematic applications, anything moving, right? It's not just restricted to linkages either. It could be, drop, because it can do 3D contact. So you could do like dropping a bunch of marbles on a table, and you'd actually see them bounce around and roll in certain patterns and things like that. So there's more dynamic applications for it too, if you're interested. Oh, one quick kind of falls under the simulation umbrella tool that you also get with SOLIDWORKS Premium is called SOLIDWORKS Sustainability. So this is a life cycle analysis tool, basically to look at environmental impact. So it allows you to basically say where your product's being made, what manufacturing process, and kind of test some what if scenarios as far as does it make more sense to manufacture it here or manufacture it overseas, and what does that do to the carbon footprint, these different parameters. So if you do have any interest in optimizing, basically reducing environmental impact, that's what SOLIDWORKS Sustainability can help with. And it allows you to do that same quick change and see environmental impact on the part or assembly. But I want to step away from simulation now, because again, we're going through these pretty fast paced, and take a look at routing. So routing is another big reason people will go to SOLIDWORKS Premium. And it's basically an automated system that allows you to drag and drop in connectors and produce routes, either for pipes and tubes or for electrical wiring applications. So it's used in processing industry where we have tanks with piping. It's used in pneumatics for tubing, and it's used in a lot of electronics for representing wiring harnesses and things of that nature. So I'll just show you a quick overview of how that functions. I'm going to load up my routing add-in here. And I'll open up a big piping assembly, a larger one, and show you basically how this would function. So this would be like a piping skid with multiple tanks and things, and we can see some pipe runs already on here. So these are things that you could produce using just sweeps in SOLIDWORKS and sweeping cylinders and adding in manually mating in valves and things like that. But it's just it's kind of a slow process, and if you're doing the same type of pipe runs over and over, that's really where the routing tools come in, or tubing runs or wiring runs. So if it's something you need to do more than just occasionally, that's usually where people will graduate to the routing tool. Okay, and it comes with a simple library of components built in here, but ultimately it allows you to create your own custom routing libraries as well. So ultimately that's what people will do, is load in their connectors, their flanges, whatever it might be, and have that stored in, similar to your design library, storing that in the routing library. So you can just drag and drop those things in onto the model and start a route. So I want to actually look at a tubing example with you, just to have a nice simple one here, quick one. I'm going to open up this air supply cabinet here, and I have a display state set up so we can just look at just the tubing here and show you what making some basic route would look like. Basically, with the routing add-in, I just need to come into my tubing folder, choose the connector that I want to start with, and just drag and drop it in onto the model. These will try to auto size based to the hole, similar to the toolbox. So it knows I want a 3/8 inch fitting. I can just choose the size of the tube that I want to be using here for it. And it's going to automatically start me into a route. So if I click the check mark, it's going to start off with basically producing this little section of a pipe here, a section of a tube. And I'll want to route that over to another section down here. I can just choose that other connector and say, add that to my route. So you can see I have the two segments. And then I can either manually or automatically route between them. So I could just sketch some lines to control the path between those two, or I can choose auto route, which allows me to click between the two there and get a generated path. And the thing is, it has different possible orientations for me to choose from. So I can choose, I don't have to stick with just the path it gave me out of the box. If I'm not happy with that one, I can switch between different possible orientations. So I find the one that I like. So I might say, let's choose this one here, and I just click the check mark. Then I can come in and dimension the route path to whatever lengths I want. And right now it's just represented as kind of this crude representation, but when I exit out of the sketch, it's actually looking at data in the routing components in my routing library and determining how it should break this down. So I could have this use separate elbows if I want to, or be a formed bend like it is now. We could even do a bent tubing, like flexible bent tubing here if we want to. So there's a lot of options on how the route is completed. And there's even capability like this, if it's tubing, you can export bend coordinates on the tubing. So if you have like a CNC tube bending machine, we can actually format the output to go into there. So the power of it, again, comes in when it's not just a simple route, but say I want to add some complexity to this, I can come back and edit it and say I want to add like a purge valve or something to it. So I can just drag in a T, a tubing T here, and I can reorient that using my arrow keys before I place it. And then I have a new little pipe stub here I can drag out and maybe add a shutoff valve onto there. Right, so I could add a shutoff valve onto there. Maybe I wanted to make it a little bit longer first. Just Control Z, add some dimensions here, like that, 5 inches, and then add my shutoff valve onto it. Okay, so I can purge out excess air or whatever if I want to. So those are the types of things we can do very quickly and easily with the routing module, right? As opposed to having to manually mate components, manually position things in there. Building up this type of library allows you, with routing, to just drag and drop components in, build your own routing systems, and quickly produce drawings from them, whether it's for tubing, piping, or electrical applications. And this is a really in-depth topic, so we have whole other webinars and things just on routing if you're interested in that. But again, it's just automation for any of these types of systems. A newer capability in SOLIDWORKS Premium is what's called surface flattening, and this is probably more of a niche application. This is that capability to allow you to take a compound surface and bring it to a flat pattern. So if you're familiar with the sheet metal tools, you'll know that it can flatten, basic shapes, but we've never had the capabilities for just a general purpose flattening of any geometry. And that's essentially what the surface flattening allows you to do. So a lot of applications we've been seeing, like you kind of see here, might be for like label design. If you have a curved part and you're trying to create a label or something for it, you can unwrap that. I think we've had some customers using it for composites to figure out, how they should cut their fabric for a layup. Really, there's a lot of applications you can use this for. I think we've had customers investigating it for boat hulls, where they're complex curved shapes that they're made of metal and they would be difficult to flatten with the sheet metal tools. And here we can just click on them and flatten. The difference is it's not taking into account any material stretch because it's based off a surface. So it's not aware of any material really. It's just flattening the shape. But it will show us a prediction of any distortion in the shape, any deformation in the shape. So it can still be a really useful tool. So let's just show you how it runs here. So I have this little example where I want to look at the plastic housing here and say we wanted to produce a label or an overlay that would go on here. On this, you can see it's curved in multiple directions on top. I could just choose the surface flatten button, choose the face that I want to unwrap, and then choose an edge or point to unwrap from. And basically, similar to the FEA we looked at, it meshes the face. It actually breaks it down. So it does have an accuracy associated with it. You can crank up the accuracy and get the most accurate flat, but it will take a little longer to generate. And what we can also do is bring over particular entities. So if you wanted to, you can actually map over other edges of the model or sketches and see if they have any suffer from any distortion on the flattened state if you want to. So it's another choice that you have available to you in the flat option. So when I click OK, it's going to produce a second surface on the model that's perfectly flat and that will have any stretch or distortion baked into it from that flattening process. We can right click on that surface and show a deformation plot, and that shows us on the right here a legend of relative stretch and compression. Good question. Where do you access this flattening function? I access it from the surfacing toolbar. So if you right click on your command manager and check the checkbox for surfaces, you'll see all your surface modeling commands, and I believe by default the surface flatten button should be there. Again, it is the SOLIDWORKS Premium feature, so if you're running a SOLIDWORKS Standard or Professional license, I believe it'll be there, but it'll be grayed out. So currently it's still SOLIDWORKS Premium feature. So we can visualize this distortion. If you want to, you could even simulate some relief cuts in different areas. But it's just it can be a very handy tool to just unwrap any shape to a flattened state if you ever need that capability. Okay. Also, you can just right click on this surface and choose to export it to DXF if you want to. So if you need to say you are creating a label and you want to come up with the shape of the label and then have the artwork team, graphics design, put their artwork on it, you could simply export the shape to DXF, and then you'd have a file that you could send them that they could go in and put their artwork on as a 2D CAD format. So there's a lot of capabilities for it. Probably not doing it justice here. This is a really shallow curvature. It can do a lot of different types of unwrapping with it, but that's the essential functionality of it. Again, accessible under the surface modeling tools. So if you don't have that toolbar showing, you should also be able to get to it through your pull-down menus or through command search. If you come up into command search here and type surface flat, it might be called flatten surface actually. It needs to be within the part level, so that's why it wasn't showing up for me. Flatten, surface flatten, or under your insert pull-down menu, insert surface. There should be under here flatten, I believe. A couple last features to talk about. These are smaller or more, again, niche ones. CATIA import functionality. So with SOLIDWORKS 2017, they introduced a new import engine called 3D Interconnect that allows us to import other CAD software files like Inventor files, Creo files. You can pull those in directly. They also enabled the capability to import CATIA files, but only for SOLIDWORKS Premium. So it's a little bit of another perk of having SOLIDWORKS Premium there. You can import CATIA parts and their equivalent of an assembly, .cat part and .cat product for CATIA V5 files, and those will pull in directly into SOLIDWORKS Premium if you have any need for that. And also our costing module, costing is part of SOLIDWORKS Professional, allows for a quick cost estimation of your parts, and with SOLIDWORKS Premium, that's extended to cost estimation for your assemblies. So it actually allows assembly cost roll up to the assembly level there. Now I mentioned these are the premium exclusive functions that we've gone over so far. But what I do want to do is point you back to, this is just a quick product matrix here, just to show you everything that's also in SOLIDWORKS Professional. So we talked about everything in Premium, this linear static simulation, motion analysis, routing, the surface flattening command, costing for assemblies, CATIA import capability, sustainability. But even in SOLIDWORKS Professional, you're getting lots and lots of functionality. So you're getting our PDM standard document management system if you're on a subscription customer using SOLIDWORKS Professional. You're getting eDrawings Pro, the Toolbox Fastener Library, 2 different solutions for photo rendering. So SOLIDWORKS Visualize, which is our new standalone photo rendering tool, and PhotoView 360, which is embedded in SOLIDWORKS. Costing, of course, tolerance analysis, scan to 3D reverse engineering functionality, as well as things like the task scheduler, just productivity tools. So when you think of SOLIDWORKS Premium, I guess I just want everyone to realize that you're really getting all that, right? Not just the functions, the exclusive functions we talked about in SOLIDWORKS Premium, but everything also under SOLIDWORKS Professional. Someone mentioned CAM, exactly, great point. This is a little bit older of a product matrix. So SOLIDWORKS CAM is included, again, for subscription customers on all versions of SOLIDWORKS. So even SOLIDWORKS Standard on subscription, meaning current version of SOLIDWORKS, will have access to SOLIDWORKS CAM. Yeah, it's CAM Standard. That's a great point because that's now embedded in every single license of SOLIDWORKS, basically on active subscription. So with SOLIDWORKS Premium, you're really getting end-to-end functionality to be able to design a part, analyze it, and predict its performance ahead of time with simulation. If you need to generate renderings of it in advance to show what the final product's going to look like, you'll have that capability from SOLIDWORKS Pro, and you'll also have the SOLIDWORKS CAM capability if you need to actually machine the part to generate toolpath on it. So there's a lot, other than just these features we went over today, is all I'm trying to say. There's a lot of other capability built in there from SOLIDWORKS Pro, just from SOLIDWORKS Standard even, that is very, very useful, and we have a lot more content going over those other subjects if you're interested just let me know, and I can always help you hunt down the best video or best webinar to watch for that. So that's really pretty much everything I wanted to go over today, just as a high-level overview of those exclusive features of SOLIDWORKS Premium. So I just want to thank everyone for attending, and let me know if you have any questions. I'm happy to go back through any of these other areas that we covered in a little more detail if you were expecting to see anything else or had any questions on how any of those things operate. So again, I'll hang around here for just a few minutes. So document management, it used to be called Workgroup PDM. That's what was bundled with SOLIDWORKS Professional years ago, was a tool called Workgroup PDM. And then we had a separate tool years ago called Enterprise PDM. That was a more high-end document management system. And so now what they've done is they got rid of Workgroup PDM, and they have a tool called PDM Standard. And basically what was Enterprise PDM became PDM Professional. And the nice thing about that is that the transition between one to the other is very, very simple. So with SOLIDWORKS Professional, you're getting PDM Standard, which is basically just like a light version of PDM Professional, or what used to be known as Enterprise PDM. So it's a vault. It's a vault that lives, hosted on a server, and it's locally cached onto your hard drive, so you get the fast performance, like as if you're working off local copies of the files, but you have all the revisioning control, version control, to make sure that no one's overwriting your files or trying to access them, and you get the version history, so you can roll back if if you decide you like a previous version of the file better. So again, if you're interested in learning more about that, we have some videos on PDM Standard is what you'd want to search for. And nope, so PDM Standard, the question is going to be phased out. That one's there to stay. It's the Workgroup PDM that's being phased out. I believe, I don't want to misspeak, I think 2018, this year, maybe the last year it was included, or it might have even been 2017 was the last year you could get Workgroup. So Workgroup PDM is basically end of life, and PDM Standard is what replaced it. So PDM Standard will be here for a long time. And if you use PDM Standard, basically it's great for a small number of users. I don't know exactly what that number is, maybe up to 5 or 10 users. But if you start to hit the limits of PDM Standard, it's really, really easy to upgrade to PDM Professional. It's basically like flipping a switch on the server, essentially. Maybe I'm oversimplifying it a little bit, but you don't have to translate all your files over to PDM Professional because they're both using the same exact technology. Good question on automatic activation, deactivation. Yeah, so that's been a challenge for some of our users, single standalone license, and you want to switch licenses between different machines. There is a system called online licensing that's in the works or will be available soon. That's an alternative to using the traditional standalone licensing, where you'd use the login to log into SOLIDWORKS, and then it will automatically basically use your license. So it's not really like you're activating at that point. I'll have to check in to see if that's live right now or will be live soon. But the other thing I can point out is we have a app we wrote, because we do a lot of custom macros and things like that here at Hawkridge. We have an app we wrote that allows a automatic reminder for transferring your license. So that one's called Hawkware Tools. I'll have to just show you here. I think I just paste this in as a response. But Hawkware Tools is a collection of basically our free apps that we provide, that you can just download. So one of those new ones is deactivation reminder. So you can set basically an alarm, like Friday afternoon before I shut down, make sure I remember to transfer my license away. So that's just something we've come up with here at Hawkridge as a stopgap, but that thing's pretty effective. We do have quite a few customers using it now, that just to help remind yourself that, oh, I need to transfer my license away to activate at home. Software for SOLIDWORKS. question on CAM. I can show a quick little example of that. And a question on photo view and visualize, is photo view going to be phased out? I don't have any information about that now. I mean, I will say visualize is definitely a newer rendering technology, so it's like the future. So I can't say, I haven't heard anything from SOLIDWORKS, nothing official about it eventually replacing photo view. But yeah, I can't really say anything about it, but I would just say that visualize is the newer technology, newer engine, and I'll let you kind of think about that, where it will go. I would personally think that eventually they'll integrate visualize into SOLIDWORKS, I would think. But that's just a guess. It's just a straight out guess. I have nothing to support that. As far as CAM, since that is a great technology, we have a lot of videos and things I can send on that, but I can show you how to just activate it and just try it out if you're really interested in that. Let me see if I have yeah, so this is just the CAM. There's a bunch of tutorial parts built into it that you can access. And that would be another add-in to load up. SOLIDWORKS CAM 2018. This is just for anyone that's interested. Again, the actual webinar ended a while ago, so if you're not interested in this, feel free to take off. So SOLIDWORKS CAM gives you an additional tab on your command manager and some additional tabs on your feature tree. And there's, again, a lot of depth that we can go into here, but at the most basic level, you're defining your stock size that the part would be machined from. So I can add some stock here to represent my starting block. Defining the coordinate system where you want your 0 location to be on the part for the machine 0. Defining your machine, if I just double click on that. So various different mills, tool selections that we can load in here. And the post processor, this is the important piece. If you're going to actually try to make a part, the post processor is what translates the generated code in SOLIDWORKS CAM to the machine readable G code. And you'll see there's a whole bunch of post processors built into the software for common machines like Haas. We also have on our website a library we're building of free post processors. We have our own post processor writing team because we've been selling CAMWorks for a long time before SOLIDWORKS CAM, and basically they're the same engine. So choosing the correct post processor to export the code is very important. And then since a lot of this is automated, we could manually just program the whole part by selecting faces and edges, but you'll always basically want to start off by clicking this Extract Machinable Features button, which will recognize all the geometry on the part. And you can see here it found all these different pockets. So it's looking at the CAD model, finding these different groups, and I can generate operation plan, which will actually assign tools to those. So it assigns tools to all those different operations. And then the final step I need to do is just generate tool path. And that will show me my actual tool path, my cutting motion of the tool to remove that material. Okay. From that point, we can modify anything how we like, or we can simulate that material removal. And even do comparisons and see green will show me nominal cut to the nominal size. Blue is material I still need to remove. So in this case, I need to add a perimeter feature to rough away the outside of the part, and maybe choose a little bit smaller end mill to get that leftover material inside the pockets there. But in a really quick matter of time, you can use that automation to program, the majority of the part. And then if you want, you can double click any of these operations and you have full manual control to adjust every setting about the cutting speed, the side-to-side step over. And it's got really nice little pictures that show you what each setting is adjusting if you're familiar with machining. So pretty great ease of use there with it. So that's a quick demonstration of SOLIDWORKS CAM, and we have lots more videos on that. Also, a good question on, is there a demonstration of Visualize Basic? Is Visualize Standard is the one that comes with SOLIDWORKS. Most of the demonstrations are for Visualize Professional. That's just because most of us run Visualize Professional. So we, as resellers, we have the full licenses of everything. Like I was showing earlier, Simulation Premium, even though we were running the simulation in SOLIDWORKS Premium. So the difference between Visualize Standard and Visualize Professional, the main one is that Visualize Professional can do animations. So it can render out animations. It has its own animation wizard. And also it can do, Visualize Professional can do custom lights, point light creation, spotlight creation, things like that. Whereas in Visualize Standard, you're mostly using the HDRI background to handle the lighting. So it's a good point, though. We should definitely do a video comparing Visualize Standard to Visualize Professional. And if we don't have one up, then I'll see that someone gets around to that. Might be me. So thanks everybody again for attending. We got some great questions come in there. Hopefully I was able to answer everybody's questions. Just scrolling back through to make sure we didn't miss any. Again, obviously there's a lot of functionality in SOLIDWORKS Premium. We can't go over all of it in just one session, but tried to hit on all the major exclusive features, and then sounds like a bunch of you did have questions on CAM and rendering too, so try to touch on a couple of those. I'll probably be wrapping this session up here in just a couple moments unless anyone has any other questions. And again, we'll be posting the recording on our website. All right, I don't see any more questions coming through, so we're going to shut this session down here. Again, I'll be posting the recording up on the website shortly. Thanks everyone again for attending. Appreciate it.